Hello students. All students, previous time I discussed with you all about the Galileo experiment. In that experiment I told you that relation between the force and motion, right? If we will take a concept of force, right? After applying force, body will remain in continuous motion. So here is that condition explained by a great physicist, right? But one thing later, by Galileo experiment, we can understand for making anything into the motion, here is not a requirement of force. But after that, we get here one new concept related to the Galileo experiment. That one I am going to explain. Number one, Newton's first law of motion. Newton's first law of motion, right? So this Newton's first law of motion is the basic concept of physics. This means laws given by the Newton only. This law is very important. After that I will discuss with you all Newton's second law. Newton's second law. Our third case I will explain Newton's third law of motion. Okay or not okay? In the case of Newton's first law, I will discuss with you all about two things. Number one, rest of the body and motion. Both things, both concept I will explain here. In the case of Newton's second law, I will discuss with you all force concept, like that force is equal to mass into acceleration. And in third case, I will discuss with you all action has an equal and opposite reaction. So all these three laws have a good explanation regarding to the physics. By first case, we can understand by the concept of motion and rest thing, means when body will remain in motion, when body will remain at rest. Anything I will discuss with you all. In Newton's second law, means from where we are getting force concept, momentum concept, all these things I will discuss in the case of Newton's second law. And in the case of Newton's third law, I will discuss with you all action and reaction force. Means action means applied force and reaction force is the opposite force. All these things I will explain. One thing, first I am starting here things by Newton's first law of motion. Newton's first law of motion, right? In the case of Newton's first law of motion, you should remember one thing, very important thing, like that rest position of the object, rest position of the object and motion position of the object. And statement should be here. All students, you also should have learned the statement properly, as same like it which are given in the book only, right? So if you will see question in the examination like that, state Newton's first law of motion. So you will write the same definition which I will give you here. But one second thing here, if examiner will ask from you that explain Newton's first law, explain, not state. So on that time you can include any example for it, for getting its proper explanation, anything else. But in the case of statement, you have to write the exact words which will I give here, right? Which I will give you here. All these things you have to keep in your mind properly. First of all, I am telling that what is the definition of statement of this Newton's first law. I am telling here a body. What? A body. In it you can include many objects like that ball, table box, table, bed, anything else. A body at rest. A body at rest. Mean initially body are at rest. Right? Means remain at rest. A body at rest, remain at rest. Okay or not okay? And second concept is what? Motion, like that a body in motion. A body in motion, right, will remain in uniform motion. Uniform motion. In the case of uniform, you can include many things which can have their equal displacement, equal distance, equal velocity, equal acceleration. Many things you can include, but things should be in uniform motion, right? Unless, right? Unless and unbalanced force X, unbalanced force X on it to change its state of rest, or of uniform motion. Okay, first of all we are going to understand this statement, means what is the meaning of this given statement. Listen, a body at rest remain at rest. If you have any body, if this body is at where? At rest, this body will remain at rest permanently. If this body are at rest, if this body is at rest, so this body will remain at rest only. And a body in motion will remain in uniform motion. If you have a body, any body, this body is in motion, so this body will remain in motion. Okay, unless an unbalanced force acts on it to change its state of rest or uniform motion. Means this body will remain at rest unless acts on it some external force. Means you can change the position of this object only when you apply on this body some external force. Otherwise this body will not change its position, it will remain at rest state. And second thing you can include, if body are in motion state, so simply body will remain in motion only till that you will not apply any external force or any barrier in front of it for stopping that body. Okay, so simple meaning is there, body will remain in motion, body will remain at rest. So both these position and things you cannot change without any external force. This is the exact and real meaning of this Newton's first law. And same thing you have to revise and learn here for the examination. Okay, two things you can include in it. Number one, Newton's first law for rest state. Second, Newton's first law for motion state. Then statement you will form from as same like it that a body, listen here, statement of it, for rest a body, what? A body at remain, a body at rest remain at rest unless an external unbalanced force act on it to change its state of rest. Means this law, Newton rest law, is meant for only all those objects which are at rest position. Means body will remain at all bodies will remain are at rest position only unless an external unbalanced force on it. Okay, if you have any block, this block will remain at rest always till that you will not apply on it some external force for changing its state. Okay, not okay. If I am keeping pen this here, this pen will remain at the same state. So simply by applying some external force I can change its position, otherwise this pen will not change its position. This pen will remain its means previous any old stage or means rest stage. Okay, so this law is only for the explanation of the Newton first law at rest position. Okay or not okay? Second law for motion, Newton first law for motion object. A body in motion will remain remain in uniform motion. In uniform motion, right? Unless and some external unbalanced force. We don't know here how much force we will apply for making things into the motion, right? So we have to take here simply unbalanced force. Unbalanced force, act on it to change its state of motion, right? If you have any object, we can say this object is in motion. You can apply force on this object. You can stop this object till that you are applying force on it, right? But when you will remove your force, so automatically this object will come in the previous position, means motion state. Okay or not okay? Means we can change rest and motion state by applying some external force, right? But if you will not apply any external force, here is not any condition of some external force, unbalanced force, so on that time, on that situation, you are not be able to change the position of anything. Things will remain at rest, and those things which are in motion will remain in motion. Okay or not okay? Means you can take a best example like that. Your earth is rotating around the sun. So on that time, earth is continuously in motion. Simply you are not able to stop the motion of the earth. Okay or not okay? So we can say earth is following here Newton's first law of motion. So simply if by applying some effort, we can say by applying some effort, you will stop the motion of the earth. This is a simple imagination. So simply what will happen? When you will remove your force, automatically earth will get its previous position. It will start rotating, moving around its axis again and again. Okay or not okay? So you can include different points. Those things which are at rest, so simply will remain at rest. Those things which are in motion will remain in motion. Simply you can change both things by applying some external force. Okay or not okay? Simple one best example I am telling to you all. Listen carefully. Simply you can see this box which are present on this table. If you are taking this table as same like it, means as same like it some inclined plane. So we are going to keep this box here as same like it. So we can see this box start to move downside. Okay or not okay? But what we will see, after covering some distance, again it will stop here. Okay, why it is stopping here? Because some external force are here. We can include friction force and many other things. If gravitational force, if we will remove friction force, gravitational force, so we will not be able to stop this box. This box will remain in continuous motion. Okay or not okay? So simple I am telling here. For example, when you send a block sliding on a tabletop, you notice the sliding block shows down and ultimate stops. Right? It seems as if the block slows down at its own. This common sense conclusion is wrong. In fact, the force of friction, an external unbalanced force, is acting on the block. This force is exerted by the tabletop on the block. Okay or not okay? Right? There is also a small amount of air resistance. If we could eliminate all these forces, friction during the activity, the block would have continued in uniform motion. In other words, a body in motion cannot stop by itself. Okay, I told you now. So simply you can take a rolling surface. If you are keeping a box here, if here is not any kind of external force like that, frictional force with the surface, okay or not okay, air which are coming in the mid of it, air friction resistance and many other things, gravitational force which are acting on it. So if these force will not come on this box, so this box start moving from upside to downside. So it will not stop, it will move continuously to the last point. So we can say that if this body is in motion, so it will remain continuously in motion. You can stop it by some external. So you can take your action force, but at some times if you will not apply any external force, so we can include some different forces which are coming here automatically. These forces can be friction force, these forces can be gravity, attraction, a resistance can come here on it. So these things you can include. Some forces will come automatically, or these forces we will include in external part, external unbalanced forces. So I discussed here two things. Newton's first law in the case of rest or motion. Body will remain at rest, will remain at rest. Body are in motion, will remain bodies are in motion, will remain are in motion. So simply you will not apply there some external force on it for changing the state of the object. Okay or not? Okay. Second step I am discussing with you all, very important, that is inertia. I-N-E-R-T-I-A, inertia. So before explaining inertia, I am explaining here some example regarding to it. After explaining the example, you can understand the things properly. Listen carefully. First example we can include here. If you hit a glass window pen with a bullet. Bullet means revolver. Bullet. Okay. Only a small hole is formed in the pen. Right? The whole window pen does not break. This is because the time of contact of the bullet with the window pen is very short. In this time duration, the whole window does not come in motion. It remains at rest due to the inertia of only that portion from the window will come out from where we will fall. Yeah, we will fire by bullet only. Okay, that much glass only will come out. So this glass total window will not come into the motion. Okay or not? Okay. So we can say this is the one example. Later I will explain everything related to it. Second example we can include here a person jumping from a moving bus. In the direction of motion of bus falls forward. This is because when his foot touches the ground, the foot comes at rest, but upper part of the body remains in motion, tends to remain in motion. Okay or not? Okay. This is the second example. Means when you will come out from the bus, so simply when you will put your legs to the earth, your foot to the earth, what will happen? Your foot wants to make themselves in the form of rest only, but your upper part of the body is in motion. It moves according to the bus. Then automatically you fold in forward direction. These things comes due to the inertia only. Automatically these things are coming. You are not doing anything regarding to it. So for making yourself in safe position, what will you do? You have to make your foot for little bit far distance for making into the motion. Means you have to run with the bus little bit far distance. So we can say there, so simple these things you can include. These things are coming due to the inertia only. Due to the inertia only. In the case of inertia, I can include I-N-E-R-T-I-A. This is our new topic. Previous time I told some example related to it. I am writing here the tendency of a body. The tendency, this is the tendency, or we can say resistive property. The tendency of a body to oppose any change in its state of rest or of uniform motion is called inertia of the body. Means we can say it is the tendency. You can say resistance. Resistance means opposition of a body oppose any change in its state of rest or uniform motion is called uniform motion. So simply you can take example of bus. Simply you are sitting in the bus, you are at rest, bus also are at rest. When driver will start the bus will move in forward direction. Where will you move? You will move in the backside direction. Means you won't remain at rest state. But according to the bus is moving forward direction. So you can say your body comes into the motion. But your body won't remain into the rest state, means previous state, due to the Newton's first law of motion. But according to it, you will move in the little bit backside direction. because your body wants to remain making itself at the previous position only. Okay or not? Okay. Then we can divide this inertia in three parts. Number one, inertia at rest. In the case of inertia at rest, the resistance offered by a body to change its state of, simply talking about rest only, so we'll write here rest is called inertia at rest. Inertia at rest. Different example you can include like that. Number one, I'm explaining here. Removing dust from a carpet. What will happen? We can see here. So simply, many dust particles can be present on this carpet. When you will apply jerk on it, so simply what will happen? This cloth will move away, and this dust particle will move where? Downside. Means after stretching, pulling this carpet in this direction, so this carpet moves in this direction, but this dust particle will remain at same position and moves where? Downside. So these particles can say they are at the rest position, dust particle, so this particle will remain at the rest position only. So simply you can say we hang the carpet and then beat it with a stick. Due to the beating action, the carpet moves along with stick and dust particle in a tendency to remain at rest, get detached from the carpet. You can do it with yourself also. You can take any paper, simply if this paper is stretchable, when you will hit it by heavy things, what will happen? That stretching things will press downside or little bit comes upside, but these things which are present on the this rubber box, so simply will remain at the same position. One example also you can include here. When you will hit a striker, this is a glass, you can see one coin are present on this cardboard. What will happen? When you will hit a striker on the pile of carom coins, you will observe that only the lowest coin moves away, and the rest of the pile coins in the original position. We can say there we have simply a pile of a coin. Okay, if you will hit any coin like that, what will happen? Other things will come downside and this coin will move outside state. Okay or not? Okay, I'm taking one example for it. Listen. So we have a bulk of all these books, right? So simply when I will stretch this copy from all these books, bulk of all these books, what will happen? This copy will come out, but nothing will happen with these books. Okay or not? Okay, we can say there these things are at rest position, will remain are at rest position. If you will take any copy from all this bulk of the books, so nothing will happen with the group of the books. Okay, so simply this copy will come out. Okay, you can include one more example also. We can see here this coin state. This coin state means we have a glass, we are keeping cardboard, and on it we are keeping one coin. Simply when we will hit this cardboard in the forward direction, what will we see? This cardboard will move in the forward direction, but the coin moves where? In downside direction. So we can say this coin at rest position, one remains at a rest position, but we are applying force on it, nothing will happen with this coin. Okay or not? Okay, so this is the simple example of the inertia at rest. Okay students. Second kind we can include inertia of motion. First of all, we will include all those bodies which are in motion state. Okay, means those bodies which are changing their position point to point. So we can write a definition of it that the resistance offered means this is, I told you that inertia is kind of resistance, opposition, tendency which comes automatically when body is in motion. Simply if we want to stop ourselves, we will not be able, because we can stop our food, but our body will remain in motion state, right? So we can say here the resistance offered by a body to change its state of uniform motion. State of uniform motion is called inertia of motion. In it we can include many examples. Very simple and most common example I can include here. Simply, if a person jumping from a moving bus in the direction of motion of bus falls forward. Okay or not okay? This is because when his foot touches the ground, the foot comes at to rest, but upper part of his body remains in motion, tends to remain in motion. Okay or not okay? So on that time, upper parts of the body tends to remain in motion, but foot comes at a rest only. Due to this, he fall in a forward direction. Due to only he fall in the forward direction. First of all, for saving himself, he have to run little bit far distance along with the bus only. Okay or not okay? We can include many points also, that when we switch off a fan, it continues to rotate for a while due to inertia of motion. Means instantly, automatically, it will not stop. It will continuously remain in motion, because due to the first law of motion, if those things which are in motion remains in the motion state. Why? Due to the first law of motion. But it comes due to the inertia only. Okay or not okay? Second thing, third point, we can include in it inertia of direction. So simply in this case, we will include the direction concept. Which concept? Direction concept. Okay. So simple definition I'm telling: the resistance offered by a body to change its direction of motion is called inertia of direction. In this case, you can include simple one, that in this case we can include direction concept. Means simply giving you one example, that when a bus suddenly takes a turn. Okay or not okay? Bus suddenly takes a turn. What happened? The passengers sitting casually experience a jerk to the outward direction. Okay or not okay? If bus is taking jerk, means a turn in this direction, passenger feel a jerk in the outward direction. Okay or not okay? This happens because the passenger tends to remain in its original direction of motion due to inertia of direction only. And some more example also we can include in it. If suppose a stone tied to a string. Simply we have a stone, we will tie it by a string, tied to a string, is reeled around against the circular path like it. Okay or not okay? What happened with it? What happens when the string is cut? We will cut the string. What happened with the stone? The stone flies off tangentially due to the inertia of direction only. Means simply we can say, if it is rotating around this fixed point, if you will cut this thread from the mid only, what will happen when it will showing a continuous rotation? After cutting it, it will move as same like in this direction, which will be in the direction of tangent of this circle. Okay or not okay? So we can say there these things comes due to the inertia of direction. So we can say here simple thing, in the case of inertia of motion, in the case of inertia of rest, or in the case of inertia of direction, so those things which come due to by storing its force in it only. Okay, so these are the simple explanation about the inertia. Okay students, prepare notes along with the explanation.